This is the outline of the talk. I will resume why the color of the blood on the shroud is a problem, attempts to find an explanation, previous attempts, our results, preliminary results, using ultraviolet plus high bilirubin blood on linen, some spectroscopy clue, and finally a summary, repetita iuvant. One of the most amazing characteristics of the Shroud of Turin is the reddish color of the blood marks. If you think blood marks on the shroud are at least several hundred years old, that's quite strange. And this problem attracted the attention of a number of scholars. And the first scholar was Macron, who said, okay, that's very simple. It isn't blood. It's just pigment. But there is a large body of evidence that tell us that Macron was wrong. There is blood, not pigments. The second possible explanation was given in a paper, mentioned in a paper by Rogers and Arnoldi, who mentioned that Diane Soran used blood stain on a saponaria washed linen, and after 26 years, the blood was still red. However, I made a deep research in internet. I didn't find any paper, any data, any photograph. So we cannot take into consideration results which is claimed without data. Then it was Adler. Adler made a proposal of free bilirubin bound with albumin, which actually is a compound which is a yellow-orange. However, two independent tests, Goldoni in 2000, Svensson in 2010, had negative results with this, obtaining the negative results, showing data and peaks. The same Goldoni made a proposal in 2000 using bilirubin, like in the case of Adler, but adding UV irradiation. And he claimed the positive results, but showing only one picture immediately after the irradiation. No data on long-term effects. Then there is Baima-Bologna, which in the same years, more or less, proposed a carboxyhemoglobin, that is a compound of hemoglobin with carbon monoxide, which is a stable molecule, and it is reddish. And this hypothesis was never checked. It's just a proposal, not experimental data. And finally, there is a pigments added to blood, which is a whole idea of Van der Hoeven, which recently has been checked by a paper of Fanti and Zagotto, analyzing sub-micron particles from encrusted linen fibers, and with positive results. They found both pigments and blood. The problem is that we cannot understand how much is, if this result can be generalized. I mean, can I base results on a few sub-micron, very, very small particles? We don't know. In our work, we check these two hypotheses. We made tests to check these two hypotheses, the Goldoni hypothesis and the Baima-Bologna hypothesis. Just an introduction of the problem of the red bilirubin. Others says, as a consequence of traumatic wounds, red blood break and released hemoglobin is degraded by hepatic enzymes that convert them in bilirubin. Bilirubin bind mainly with albumin, taking a yellow-orange color. So according to Adler, this is a consequence of the scourge of the man of the shroud. As I told before, however, this hypothesis has not found a confirmation by experimental results. Goldoni proposed the modification of bilirubin by UV radiation and tested his hypothesis using a UV lamp. continuous wave ultraviolet radiation with subjective positive results, showing a single picture without colorimetric data. And most important, we don't know what happens after in a long-term period. So, our plan of experiments. We want to make ultraviolet irradiation of both high bilirubin and normal bilirubin blood on linen. Then, we will use 3 ultraviolet doses equal to those allowing a shroud-like coloration of linen, according to our previous experiments. Latent coloration of linen. I remind you, latent coloration, what is latent coloration? Is a coloration which appears after aging of the linen, following ultraviolet irradiation, which at the moment did not show any effect. So it's a long-term, let's say, coloration. And the third dose is below threshold for linen coloration, because as I will explain in the afternoon, in a talk in the afternoon, ultraviolet coloration of linen has a threshold, I mean, a minimum value of power and fluence. Above them, I have coloration. Below it, I have no coloration at all. We will use 2 control blood samples. One with normal bilirubin irradiated, and the other with high bilirubin not irradiated as a control. And finally, we will check colorimetry results immediately after irradiation and 4 years later. So actually, I'm discussing an experiment which started 4 years ago. And we waited 4 years to see long-term effect. This is the blood we used with high bilirubin. It was from a male, 45 years old, diagnosed by jaundice with hepatitis HBV. Total bilirubin 8 times larger than the maximum normal range. Conjugated bilirubin, say 21, 22 times larger than the highest value in the normal range. Hemoglobin and albumin almost normal. These are the blood stain on linen we have used. All these blood stains are with high bilirubin content. And this is a picture of one of these blood stains seen through a lens which was focusing the ultraviolet laser light. So we start with the laser irradiation at a UV power level apt for shroud-like coloration. And these are 2 blood stains before irradiation. And this is what happens after laser irradiation. You see here, there is an ablation of blood, here and here. We send the laser not to cover all the blood stain in order to see the difference between irradiated part and not irradiated part. So the blood is ablated using a power level of UV able to color immediately the linen. And then we made the laser irradiation at a UV power level apt for latent coloration. That is a coloration which appears after aging linen, even years after irradiation. There is no ablation. And we have a subjective feeling of a color turning reddish. Finally, we use a black lamp, low power lamp. The samples were put at 6.5 centimeters from the lamp, and we irradiated 3 milliwatt UV at a total UV fluence of 0.14 joule per square centimeter, which is not so small because it actually is the same fluence that can generate a laser coloration, but if it is concentrated in a 10 nanosecond pulse width. In this case, the pulse width is continuous. So the fluence is that useful for generating a linen coloration, but the power is many, many orders of magnitude less. And finally, we have to do the color analysis. Just a summary, we made the calibration of red, green, blue on reference white. Then we selected the elliptic area inside the photograph of the blood stain. And finally, we obtain by commercial software an histogram channel, giving the average value inside the elliptic area about red, green, blue, and color tone, saturation, and luminance. The last three are used for normalization purpose only, but actually this was the initial idea, but we didn't need to use a normalization because for all the blood stain, photograph of blood stain, color tone, saturation, and luminance were comparable. So we didn't need to use it. And these are the results. What's about redness? Redness can be estimated in two ways. I can calculate the red part divided by the total red, green, blue components, or I can calculate the red divided by the remaining part of the spectrum, green and blue. The results are the same trend. Here is just more prominent, is just more visible than here, but the meaning is the same. Sorry. So what happens? This is the initial, the not irradiated value, the not irradiated blood, which has a redness, say 0.68. After 1 day irradiation, both laser and lamp increased very much the redness. The control sample, of course, has the same value. But after 4 years, the redness of the laser irradiated blood stains reduced very much at the same level, almost at the same level of the not irradiated blood stain. On the contrary, the lamp irradiated blood stain maintains much higher redness content. But we are not looking to reds alone. We are looking to a reddish that is a mix between yellowing and redness. So we must consider the yellow part. And these are the results of the yellow part. Again, this is the initial value. Both laser and lamp increase the yellowing component, but after 4 years, laser goes down and lamp increases. So, how can we summarize? These are the results, redness and yellowish after 1 day after irradiation. And you see here the increment of laser irradiated and lamp irradiated redness compared to the initial value, to the basic value. And note that the normal blood, the normal bilirubin blood did not change after irradiation. Only bilirubin changed after irradiation. Normal bilirubin blood stain had the same value of the control sample, not irradiated sample. More or less the same for the yellowish part. The normal the normal bilirubin has almost the same value of the not irradiated blood stain. On the contrary, laser irradiated and lamp irradiated increase. After 4 years, what happens? You see here, the laser irradiated blood stain redness dropped down 18% less, compared, has almost the same value of the not irradiated blood stain. On the contrary, the lamp irradiated redness is almost at the same level like at the beginning, after 1 day, I mean. And the yellowish has more or less the same behavior than the reddish part. In every experiment, it's very important to understand the limit of the information we obtain. In our case, for the reason explained here, our experiments has a high level of bilirubin due to hepatitis that is different of the bilirubin obtained after scourging. So our experiment is not suitable to check the Adler hypothesis. But our experiment is perfect to check the Goldoni hypothesis, because in the Goldoni hypothesis, the relative weight of free and conjugated bilirubin is not a relevant issue, because we are looking to a photochemical effect on the bilirubin triggered by the UV light. Spectroscopy. This is the most recent reflectance spectrum measured on the Shroud of Turin in 2015 about the blood, body image, background, and burned part. And you see that among all these lines, the only line showing an inflection is the blood one. You see, there is a sigmoid, like S shape. What's the meaning of the S shape? Spectroscopy people pay much attention to the change of the slope. This is the initial slope between, first of all, on the vertical line, I have the absolute reflectivity. On the horizontal line, I have the wavelength, that is the color, say the color of the reflection from the blood of the shroud. And you see, this is the slope, the straight line between 380 and 550 nanometer. At 550, the situation changes, and there is another slope, completely different. And this is very important for spectroscopy people, because they can gain some information. They can look why there is a so strong change of the slope. The same inflection is noted in the absorbance spectrum, which is shown here, still at 550 nanometers. And then we have to look at the absorption and reflection of several substances. In particular, this is the absorption spectrum of hemoglobin, the deoxyhemoglobin, carboxyhemoglobin, and methemoglobin that are it's not working anymore, okay. That are specified here. And you see that the line dot line is the methemoglobin, which has a strong inflection exactly at 550 nanometer. So it is possible that the inflection we note in the absorbance and the reflection part of the blood of the man of the Shroud of Turin is due to the presence of methemoglobin. What is methemoglobin? It's a strongly oxidized hemoglobin that is very, very old blood. It's a very old blood. At the same time, there is the carboxyhemoglobin spectrum, which has two very strong change of slope inflections at about 530 and about 580 nanometers, which I don't observe on the blood of the man of the Shroud. So this means carboxyhemoglobin is not present in the blood of the Shroud. Conclusion. We have tested the hypothesis of Goldoni that ultraviolet radiation may change the bilirubin structure to enhance the reddish color of blood stain over a long period. Our preliminary results show that a continuous wave low power lamp ultraviolet irradiation of high bilirubin blood stain generate a permanent color shift toward the red-yellow. On the contrary, ultra-short nanosecond duration UV pulse irradiation by laser produces a reddish color shift of the blood stain at the moment, but after 4 years, the effect disappears. What about spectroscopy? We have observed an inflection at 550 plus or minus 10 nanometer in the spectral reflectance absorbance of the Shroud blood stain measured in 2015 and in 1998. They are perfectly coincident. This inflection, actually, I checked, is visible in the Gilbert measurement of the Shroud of Turin research project, but the recent spectra, the spectra of today, are by far more accurate than those in 78 and show a better sigmoid shape as expected. The observed spectral inflection on the Shroud of Turin is not compatible with the presence of carboxyhemoglobin proposed by Mabolone to explain the color of blood stain, while it is perfectly compatible with the presence of methemoglobin, that is very, very old hemoglobin. We believe that these spectroscopy results, is an additional evidence that blood stain on the Shroud contain very old blood. So thank you very much for your attention and for your passion for this technical presentation.
It's all right. So that was fascinating. So now, next up is Jose Godinez. Is Jose here? I mean, I'm Jose Carlos. Okay, Mark, where are you? We'll get to Jose Carlos later, and we're gonna jump over to Mark Antonacci. He was here a second ago. Anyone know where Mark went? Probably just went out to the men's room or something. So we'll just wait. Yes.
Can I make some?
Yes.
Yes.
It's your show.
It's my show. Just some random thoughts here. Okay, while we're trying to find our next speakers, I just want to thank everyone for all of your help and your participation. It's been amazing. We wouldn't have this facility, we wouldn't have the conference, we wouldn't have the speakers without everyone helping and participating in this, especially our people coming. Just think how far they've come, many of them. It wasn't difficult for me. I just lived 12 miles from here.
I was born in France.
This is important.
So just thought I'd point that out.
Yes, you came a long way before. Russ, you've come a long way.
A long way.
I'm sorry? So just to mention some, just the individuals coming from Italy, Spain, France, Australia, other countries, South America, India. Yes, some of the attendees came a long way for this. My wife took care of the registration.